All right, so this is day one of the rational functions unit. Unit 4, we're going to start off by talking about multiplying and dividing rational functions. So a rational function is really just a fraction that is made out of polynomials. Okay, and we're going to be multiplying and dividing those. But before we do that, I always like to go back and talk about more simple problems, like if we multiply or divide with basic numerical fractions. So I'm going to pick two numerical fractions, and I'm going to go up here just in the top corner for a second. All right, and I'm going to talk about the fractions 2/3 and 3/4. All right, so if I take 2/3 and 3/4 and I just multiply those, okay? To do that, what we have to do is we multiply across the numerators and then we multiply across the denominators. So I would multiply 2 and 3, and then I would multiply 3 and 4. Okay, so to get my answer, 2 times 3 is 6, and 3 times 4 is 12. Right? But is that my final answer? Seems simple enough, but I'm not done yet. You're not going to give me 6/12. You're going to tell me that 6/12 is really just 1/2, right? We have to simplify every single fraction, if it will simplify, before we're finished. Okay. And when we do rational functions, we also have to worry about simplifying. So here's what we're going to do. We're actually going to make the process a little more simple and simplify as we go. Because if we don't, what I don't want to do is have to multiply straight across the numerator here and straight across the denominator here. That means I'm going to have to take 3x cubed and x squared minus 64, right? And then I'm going to have to distribute that 3x cubed into the x squared and the negative 64. And that's just going to make the polynomial bigger. And that's going to make things harder. I don't want to make things bigger. I want to make things smaller. That's my whole goal. So what I'm not going to do is try to distribute all of that. Okay, so if we go back up here to my simple problem, what really happens when we simplify basic numerical fractions like this is we're breaking down each numerator and each denominator into its prime factorization. Okay, it's probably been a while since you've heard that word, prime factorization. All right, so what the prime factorization is I'm going to take 6 and I'm going to break it down into its factors as far as it will go until the numbers that I have left will not break down anymore. Okay, so if I take just the 6, oops, sorry, I need my pen. If I take just the 6, all right, the 6 is up top, and I break it down. Well, what are the factors of 6? Well, I could use 6 and 1, right? But that doesn't get me anywhere, doesn't give me any smaller numbers. So I'm going to use 2 and 3, all right? So 2 times 3, that's equivalent to 6, right? So those are equal. All right. But if I look at 2 and 3, do the numbers 2 and 3 break down any further? And the answer is no. It's because they are prime numbers. A prime number is a number that's only divisible by 1 and itself. Okay. Which means I can't break it down into any more factors. All right. So that's what I want. I want all the numbers left in the prime factorization. All right. So I'm going to take 12 and I'm going to do the same thing. All right. Well, I'm going to go same route. I'm just going to pick a set of factors of 12. Okay, I'm going to start with 3 and 4. You could start with 6 and 2 if you wanted to. So 3 times 4, right? So I'm breaking these numbers down. Okay, well, if I look at 3 and 4, I know 3 is prime. I can't break 3 down any further. But if I look at 4, I absolutely can break 4 down a little further, right? 4 breaks down into 2 times 2. Okay, so really, this fraction is equivalent to 2 times 3 over 3 times 2 times 2, because 3 times 2 is 6, times 2 is 12. Okay, so really this is 6/12. And what we do is we don't cancel stuff out. Okay, it just doesn't disappear. What's happening is these numbers are simplifying out to 1. Okay, so if I look, everything's broken apart by multiplication, which means I can look at factors separately. If I look right here specifically, I got a 2 divided by 2. Okay, well, what is 2 divided by 2? Well, it's the same thing as x divided by x, or 5 divided by 5, or 1 divided by 1, right? Those things simplify out to 1, right? So that would be the same thing as 1 times 3 over 3 times 2. All right, which means I just pulled those 2's outside and I simplified them to a 1. Well, do I really need to multiply anything by 1? The answer is no, it's not going to change anything. So I just get rid of it. And that's why people call it canceling out, but it's really not canceling, it's simplifying out to one. Okay. And there's one more set I can do this with. I can do this with the threes. They will simplify out to one as well. What am I left with? Well, I'm left with the two on the bottom, right? And when there's nothing left up top, I can't just leave it empty, right? Everything's simplified out to what number? Well, it's simplified out to one. So I have to put a one in its place up top. So it simplifies out to 1/2. Okay. So that's the process that actually takes place when we simplify fractions. So if we think about that when we talk about rational functions, I have a lot more going on down here. Now I've thrown in variables and I have polynomials everywhere, right? So what I'm going to do, okay, is I'm going to break everything down first. All right, that's going to make my life a lot more simple, and I can look at each numerator and each denominator separately. So I'm going to look at x squared minus 64 first, just the first numerator. Okay, so I'm going to start step number one, and I have all your steps written out up here on the top. Step number one, factor the numerator and denominator of each rational expression. Okay, so x squared minus 64, this is difference of perfect squares. The square root of 64 is 8, so this breaks down into x plus 8 and x minus 8. Okay. And if you're having any trouble, like, oh, okay, where did he get that 8 from? Probably need to go back and look at some of our notes in the polynomials unit that we just came out of. All right. That's where you'll find all the explanations for this. All I done was take the square root of 64. All right. So I'm not going to talk a lot more about the factoring process. I'm just going to go. All right. So the 7x on the bottom, now we know that we can't factor 7x. It's a polynomial or a monomial that doesn't factor, right? But what I'm actually going to do is I'm going to pull apart the 7 and the x, because really it's 7 times x. Okay. So I'm going to pull apart the 7 and the x. And there's a reason I'm going to do this, and I'll show you here in just a minute. Okay. So that's the first one. All right. Now I'm going to go to the second one. Okay, so in the numerator of the second fraction, I have 3x cubed. I'm going to do the same exact thing there. I'm going to pull that 3 and that x cubed apart. So 3, all right? But then x cubed, I don't want to just leave it as x cubed. I'm going to break it apart too, because it will. All right, x cubed is no different than 5 cubed or 10 cubed or 11 cubed, right? That's 5 times 5 times 5 or 10 times 10 times 10. So this is really x times x times x. I'm actually going to break it down into that. All right. So, and then the bottom denominator on the last fraction over here. All right. That is a trinomial. Now I'm not going to go through the box method in this video. If you want to go back and look at your notes on the box method and stuff, that's fine. I'm actually going to use the quick way that I've shown y'all to do this. All right. So I'm going to take my x's and I'm going to split them. All right, x squared, x on each side. And now I'm just going to look for the factors of negative 72 that are going to add back to a positive 1, which end up being a positive 9 and a negative 8. Now, that being said, if you want to use your box method through this whole thing on every single trinomial, that is okay. You can continue to use your box method the whole time, and it will get you there. It's just going to take more time. So if you can get toward not using the box method as much, especially on these more simple trinomials, I promise it will be worth your time, because it makes everything a lot quicker. All right. So now, let's go back to what we talked about. To multiply fractions, we have to multiply across the numerator and across the denominator. Okay, so I'm actually not going to turn around and distribute all this. That's going to undo everything that I just done. Okay, so what I'm actually going to do is when we have everything factored like this, all right, you see everything's in every single factor besides just the numbers are in a set of parentheses. All right. When we take things in a set of parentheses and we push them up beside each other, right? If I take x plus 2, right, and x minus 1, right, and they are pushed right up next to each other right here. There's no space in between them. All right. We know that means to multiply. Multiplication is the only operation out there that you can perform without putting a sign in it. Okay, so we don't actually have to write the multiplication sign. So really, you can just push everything together to multiply it. So if I take this whole thing, right? If let's see, if I have if I have some kind of press right here, right, and I press all this stuff together, I just kind of squeeze it together, right, I'm going to push it all into one fraction. And that's exactly what I'm going to do. So I'm going to just extend my fraction line and say, hey, now I've multiplied, right? Everything's all in one fraction. I've pushed it together, but I want to keep everything in factored form because it's going to prep me for simplifying here in just a second. Okay, so now that I've done my multiplication, I'm going to simplify exactly the same way I did here. Notice I found matching factors on the top and the bottom that simplify out to 1. 2 here, 2 here, they simplified out to 1. I could get rid of them. They're no longer needed. So I'm going to do the same thing down here, right? So I'm going to find matching factors on the top and the bottom. For example, let me change my color. For example, x minus 8, x minus 8. I no longer need them. They simplify out to 1. Okay. The x plus 8 doesn't have a match on the bottom. You have to have a match on the top and the bottom. Okay. And it's only one set. If you have two x plus 6s, let's say I go somewhere else and I have two x plus 6s, right, on top, plus 6, and then an x plus 6 on bottom, right? That doesn't mean, hey, I can just cancel all of those. I can't do that, right? It's one on top, one on bottom. So I can only cancel one set of those, and then one x plus 6 would be left on top. Okay, so I have to make sure I follow my rules. All right, so the reason I broke those x's up a minute ago is because if you notice, it's not just binomials that I'm going to simplify out to 1. It's also single terms. So check this out, x. And if I would not have broken those down, I may not have seen that, right? So I can know what stays and I know what goes. All right. So there's nothing else to cancel at this point or to simplify out. All right. So my final answer is just going to be everything that's left. And no, you're not required to multiply everything out when you're done. So everything that was left on the top was a 3 and 2 x's. So I'm going to multiply those back together, right? X times x is x squared. So 3x squared, right? And an x plus 8. That was everything that did not simplify out on the top. All right. And on the bottom, I'm going to do the same thing. Everything that did not simplify out, just pull it back down. So 7 times x plus 9. Bang. All right. So again, you do not have to turn around and do this. Okay. You do not have to distribute everything. All right. It is not necessary. That answer that you have is correct. And I'm finished. All right. And that was a lot better. And I know that took a minute to do a more simple problem. I wanted to explain everything, but that was a lot better than having to multiply and distribute everything and then go back and factor everything as really big polynomials. I don't want to do that. Okay. So factor everything first, push it all together, simplify out what you can. All right. That's our process. And remember, your steps are up here on the top of the page. Okay, so I'm going to move on and I'm going to pick up the pace a little bit and I'm just going to dive into factoring. So if I start factoring here, so first numerator, all right, x squared minus 64, that factors into x plus 8 times x minus 8. All right, x minus 8 on the bottom in this denominator right here does not factor. Okay, so I'm just going to pull it down, but it is a binomial. That x and that 8 are married by that minus sign, so I am going to put a set of parentheses around it. All right, second fraction. Okay, x plus 5, same deal, can't factor. It's a binomial, so I am going to give it its own set of parentheses. And the bottom, let's see, I have another trinomial, so I know I'm going to get two binomials when I factor. Again, you can go through your box if you like. I'm going to do the quick way, so split my x's. All right, and the factors of 40 that add back to 13 are going to be a positive 5 and a positive 8. All right, so there's everything factored. Push it all together, right? I just extend the fraction line instead of rewriting it. All right, so push everything together and simplify out what I can. So plus 5 plus 5, plus 8 plus 8. I should be using green, shouldn't I? Plus 5 plus 5, plus 8 plus 8, minus 8 minus 8. Whoa, something's not right here. Well, my answer is always what's left, right? Well, in this case, there's nothing left. There's nothing left here for me to have an answer with. Well, remember, what did everything simplify out to? X plus 5 over x plus 5 simplified out to 1. X plus 8 over x plus 8 simplified out to 1. So when you have nothing left, remember, just like we did up here, we had to put that 1 when there was nothing left in the numerator, right? We had to put that 1 in there. There was nothing left on top, right? That 3 canceled out or was simplified out. It was gone. So here I have to do the same thing. So there's nothing left in the numerator or denominator. So it's 1 over 1. Oh, what's 1 divided by 1? 1, right? So if everything simplifies out and goes away, your answer is simply just 1, okay? So you can see stuff like that as well. All right. So moving on to number 3. All right. So make sure, remember our factoring tree or our factoring list, right? Number 1 on the factoring list is GCF. You cannot forget to check for a GCF everywhere that you go, right? So for example, in this first numerator right here, I have x cubed plus 9x squared. I have to factor out a GCF there. Remember, a GCF does not have to be just a number, okay? I can factor out a GCF that is a variable, all right? So notice that I have 2 x's here, 3 x's there, okay? Oop, I should be using red, shouldn't I? I have 2 x's there, 3 x's there. That means at most I can take 2 x's from each person. Remember, we have to be fair. So x squared comes out. What am I left with? I'm left with an x plus 9. Okay, so in the bottom, again, I'm going to separate that 2 and that x. So 2 times x. All right, moving on. Next numerator. All right, I've got x squared minus 14x plus 45. So split my x's. All right. What are the factors of 45 that add back to a negative 14? I should be looking for a negative 5 and a negative 9. Remember, sometimes both of them can be negative depending on how your signs are in the trinomial. All right. And then on the bottom, I have difference of perfect squares again. X plus 9, x minus 9. All right. So everything's factored. I'm going to perform my multiplication. All right. My fraction line is extended. I'm going to simplify out what I can. All right. So let's see. X minus 9, x minus 9, x plus 9, x plus 9. Right. Here's everything I have left. I have an x squared up top and an x minus 5, and then a 2 on bottom and an x. But wait. This is why I always separate those x's. So notice in number 1 up here, I took that x cubed and separated into x times x times x, okay? I didn't do that down here. I left this x squared, right? This x squared is still there. I didn't break it down into x times x like I should have, right? So I'm going to break that down into x times x, okay? Well, if I do that, then I notice, hey, one set of these x's will cancel. That's why we always break those x's down, because it's easy to miss those, okay? And if you haven't simplified everything out all the way, then your answer is not fully correct, all right? So one of those x's will actually go away. Oop, I keep not using the right color, don't I? So there is everything that simplifies out, all right? So what am I left with in my final answer? So I should have, in my numerator, I'm left with an x and an x minus 5. Okay. In my denominator, everything's gone but the 2. All right. And that is my final answer. All right. Okay. Moving on to number 4, and you're welcome to pause the video anytime you need, if you need to look at something or, whatever you need. And if you have questions, Mr. Twing can help you out. I know he can. Let's see. So start factoring. X plus 5 doesn't factor. Awesome. All right. Let's see. 9x plus 27. Hey, I got a GCF there. 9 and 27, both divisible by 9. So let's see. X plus 3. Okay. Second fraction, difference of perfect squares. So I have a 9 there. So x plus 3 and x minus 3. All right. And remember, this video is not going to get into the specifics of factoring. At this point, y'all should already have a handle on factoring. If you're having trouble with that, you need to go back to the polynomials units notes. All right. So in the bottom, I have a trinomial. All right. X squared plus 2x minus 15. All right, let's see. So split my x's. All right, the factors of negative 15 that add back to a positive 2. Let's see, negative 3 and positive 5. Okay, so everything's fully factored at this point. Extend my fraction line, change my color this time, and simplify what I can. Okay, so let's see, plus 3, minus 3, minus 3, plus 5, plus 5. Well, wait a minute. This one's almost the same as number 2. In number 2, everything's simplified out, but in number 4, not quite everything simplified out. We can't forget that little itty bitty 9 right there. Okay, does that mean my answer is 9? No, not at all. All right, notice where that 9 is at. That 9 is in the denominator. You can't just pull things out of a denominator because you feel like it. Okay, it has to stay in the denominator. So I have a 9 in the denominator, but there was nothing left after I simplified up top. So what number do I put? 1. So my answer is 1/9. Okay, so sometimes these will not just simplify out to a 1, but sometimes they'll simplify out to another number or a fraction. All right. Number 5. Okay. Number 5 is honors level question. If you are CP and you don't want to watch this, you can continue on, fast forward a little bit. All right. This one's really, really hairy. If you wanted to stay and watch it, you're welcome to. Okay. So number 5, these are some hairier multiplication problems with rational functions. These have a lot more going on. All right. So sometimes our polynomials will factor more than once. We've seen that. We got to be careful. All right. So I'm just going to dive right into this one and start factoring. So my first numerator, 15. Oop, I didn't change my color again. 15 times x plus 6 squared. All right. So I have a 15. Part of this is already done for me. All right. I have a 15. Okay. But I have x plus 6 quantity squared right here. All right. What does it mean to square something? That means multiply it by itself. Well, just like x squared is x times x, x plus 6 squared is x plus 6 times x plus 6. So really, I have 2 of those right here. X plus 6 times x plus 6. All right, so there's that numerator. The denominator, woo, those are some big numbers. 15, 60, and 900. Remember, what are we always going to check for first? Got to look for that GCF. So does 15, 60, and 900 have a GCF? Remember, you can go to Desmos, right, and you can type in GCF. Okay, open a set of parentheses, put your numbers in there separated by a comma. All right, and then you can just get the GCF from there if you need to, if you don't know it off the top of your head. Okay, that is an option, but you don't have to. All right, so 15, 60, and 900 absolutely have a GCF. They are all divisible by 15. So I can pull out a 15, right? And then what am I left with when I pull out that 15? Well, I'm left with x squared. Okay, 60 divided by 15 is negative 4x, right? And then 900 divided by 15 is 60, so minus 60. Okay, so here's what I'm left with. But wait, I'm not done. This is a trinomial. I got to see if it'll factor again. Okay, so are there factors of negative 60 that add back to negative 4? And the answer is absolutely yes. So split my x's, right? What are the factors of negative 60 that add back to a negative 4? Should be a negative 10 and a positive 6. Negative 10, positive 6. So I'm not using this one anymore. I'm using the bottom. Okay, pull that 15 down. He is still a factor. All right, so I'm using the bottom. That is fully factored. It factored twice, once with GCF, once with trinomial. Okay, moving on to the next one. All right, same deal in the second numerator. Check out those exponents. I've got a 5, a 4, and a 3. I can take some x's out. That's an automatic indicator. If I have enough x's to take in each one, I got to take them. Okay, so I have a GCF here. Remember, it doesn't have to be a number. It can be a variable. All right, so I'm going to take, let's see, at most I can take 3 x's. So x cubed. All right, and if I take x cubed out of each one of those, all right, I'm left with x squared minus 7x minus 30. Okay, got to see if that trinomial will factor again, right? So 2 binomials. Pull up my x cubed. Don't forget about him. All right, x, split that x squared in half. Are there factors of negative 30 that add to negative 7? Absolutely. I've got negative 10 and 3. So minus 10 and plus 3. So now I'm using the top one, not the bottom, right? I factored that twice. All right. And again, same deal in the bottom. So these things can get big really quick. All right. I can do it again. So factor out GCF first. So here I can take x squared, right? What am I left with? I'm left with x squared plus 9x plus 18. Okay. Can I factor that trinomial again? Absolutely. Right. Split my x's. All right. What are the factors of 18 that add back to a 9? I should be looking for plus 6 and plus 3. All right. So now I'm using the bottom. So some of these factor more than once. All right. So I'm just going to come down here and I'm going to rewrite all of that out so we don't get confused. So I'm going to get rid of these. All right. I'm going to write the fully factored version. So I have 15 times x plus 6, x plus 6, 15, x minus 10, x plus 6, all right, times x cubed, x plus 3, x minus 10, and x squared, x plus 6, x plus 3. Okay, and again, you can absolutely break these up into x times x times x on top, and then x times x on bottom, right? We got to make sure we know that. So x times x here, and x times x times x here. Okay, so now I can finish my fraction line. There's a multiplication. That's actually the easiest part. Simplify out what I can. Okay, so back to my green. Let's see, plus 6 plus 6. All right, minus 10 minus 10. Plus 6 plus 6. Plus 3 plus 3. Let's see, 15, 15. All right. So really, what am I left with? Well, I'm left with x cubed over x squared right here, right? But some of those will cancel as well. Okay. So I have here, 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 here. So 2 sets of those will go away. What does that mean? That means I'm just left with an x on top. Everything else has gone away. Okay. So that means I'm still left with an x on the top. Well, what number do I put on the bottom when everything simplifies out? I put a 1. Well, does it matter when we divide things by 1? Dividing by 1 does what to us? Nothing, right? So really, my answer is just x. A lot of work to simplify down to something really simple, okay? So that is multiplication with rational functions. And I can't show you everything, right? There's too many different situations out there, but this should give you a really good handle on what you're going to see on Delta Math and in class with Mr. Twing. Okay. All right. So moving on to division. All right. So I'm going to go back to my same basic fractions. All right. So what fractions did I have? I think it was 2/3. Yep. 2/3 and 3/4. So 2/3, 2/3, and 3/4. But now I'm going to divide them. Well, great. Does that mean I divide straight across the top and straight across the bottom? Heck no. Absolutely not. Don't want to get into that. Okay. When we divide basic numerical fractions like this, okay, what we have to do is we actually have to turn it back into multiplication. All right. So this is going to be really, really similar to the stuff that we just done. Okay. So what I'm going to do is called multiply by the reciprocal. All right. A reciprocal, for example, 1/2. All right. The reciprocal to 1/2 is 2/1. What does that mean? I just flipped the fraction. All right. Has anybody ever heard keep, change, flip? You keep the first fraction, you change division to multiplication, and then you flip the second fraction. That's multiplying by the reciprocal. Or some people see it as the butterfly method, right? Butterfly, same deal. Okay. So really, what I'm going to do is I'm going to take 2/3 and I'm going to multiply it by 4/3. Okay, so now I can multiply straight across the top and straight across the bottom because I'm telling you, you don't want to get in to doing this. That is a complex fraction. We don't want to deal with those if we don't have to. Okay, we will in the future, but we don't want to deal with those if we don't have to. All right. Okay, so multiply straight across the top and straight across the bottom. 2 times 4 is 8. 3 times 3 is 9. Does 8 over 9 simplify? No, they do not. They do not have any common factors, so I'm done. Okay, so that's exactly what we're going to do here. The only difference is I'm going to factor everything, and then I'm going to take this second fraction and I'm going to flip it upside down, and then it's just like multiplication. Okay, so division is really no different. When we see that divide sign, oh, okay, flip the second fraction. All right, so I'm going to start off by factoring. All right, so x squared minus 4, that is difference of perfect squares. So x plus 2, x minus 2. All right, 5x plus 30, I have a GCF there. I can take out a 5 from 5 and 30, so 5 times x plus 6. Okay. All right. So I'm going to factor out everything in the second fraction. So I've got a trinomial up top. All right, x squared plus 11x plus 18. All right, let's see, split my x's. What factors of 18 are going to add back to a positive 11? Let's see. I should have a 2 and a 9. So plus 2 plus 9. Okay. And then in the bottom, I have another GCF. I can take a 3 out of 3 and 27. So that is 3 times x plus 9. All right. So I factored everything. The only extra step I've added, and remember, I have all of your steps up here. The only extra step I've added is this step 2 right here. You got to flip that second fraction. Okay. Got to flip that second fraction. So I'm now going to take it and I'm going to say, well, now I'm really dealing with x plus 2 times x minus 2, 5 times x plus 6, right? Times, now flip it upside down, 3 x plus 9, x plus 2, x plus 9. And now this problem is no different than everything we just done on page 1. Okay, so see what simplifies out. All right, extend my fraction line. There's my multiplication. Plus 2, change color. Plus 2 plus 2. Plus 9 plus 9. And everything else stays. Nothing else will go away. So on top, I have 3 times x minus 2. All right, on bottom, I have 5 times x plus 6. Please make sure that we put single numbers like that in front of those binomials. We do not put them in the back. Okay, we always put those numbers up front. All right, so there is my final answer. And you also got to be careful about numbers that you have up front. Let's say you have something up front like, I don't know, 2 over 4, and then, you have 2, binomials over here. Let's say we have something like that. If you leave that, that is not correct. Okay, you have not simplified everything as far as you can, because if you look at 2 over 4, 2 over 4 simplifies. Well, what does it simplify to? Well, 2 over 4 simplifies to 1/2. All right, so I got to take that down to 1/2. So always be careful when you have numbers out front like that. Can't do that with 3 and 5. Both of those are prime numbers, no common factors. So I am done here. But just know that those instances can happen. All right, so you always got to check those numbers at the end. There's a lot of things to look for when doing rationals. Okay. All right. So because these are so similar, I'm not going to go do every single one of these on the back like I did the front. Okay. So I'm going to pick maybe another one, and then I'm going to go into the hard one for the heavy honors level question. All right. So let's see, which one do I want? Let's go into number 4. All right. Let's go into number 4. So start by factoring everything. Back to red, factor everything. So I'm going to pull those x's apart up top. X times x is x squared. All right. I have a trinomial down bottom. All right. So split my x's up. What are the factors of 6 that add to 7? Well, that's 6 and 1 plus. Okay. All right. So now I will say this as well. Some people, once you get more used to doing these, you can factor and flip at the same time. So if you want to go ahead and turn this into multiplication, we're still going to factor this x squared minus 9. I can do that, right? That is a GCF problem. This factors into 9 times x minus 1. Okay, so once I've factored everything, just don't put it back on the top. You're flipping the fraction. Take those factors and put it back on the bottom. Now, you don't have to do that all in one step. You can separate it. It just saves you a little bit of writing, because over here, I wrote it twice, right? Once with the division, once after I flip for the multiplication, okay? But over here, I'm not going to have to do that. I just write it straight as multiplication and go ahead and flip the second fraction all at the same time. You can do that. All right. So, and then factor x squared minus 1. All right. A lot of people have trouble noticing this one. That is difference of perfect squares. Okay. I'm sure we've talked about it at this point in the polynomials unit already that we finished. 1 is a perfect square. Okay. So we cannot forget that this is difference of perfect squares. So x plus 1, x minus 1. All right. So run my fraction line together and simplify out what I can. All right. So let's see. Plus 1 plus 1. And that, minus 1 minus 1. And that is it. Everything else stays. Nothing else will simplify, and I have no numbers to worry about on top and bottom. All right. So pull everything into 1. So I'm going to push those x's back together. So that's x squared up top. All right. And on the bottom, I have a 9 left, and I have an x plus 6. All right. And there would be my final answer. Okay. And again, if you need to pause to look at something, you absolutely can. All right. If you have any questions, absolutely reach out to Mr. Twing. You're welcome to email me. I don't know that I'll email back right away because I am on my honeymoon at the moment. So if you have any questions, please get those answered. I know this is a lot to think about at once. All right. So again, honors level question. If you're in my CP class, you can move on. If you want to stay and watch this one, you absolutely can if you're curious, but you do not have to stay. All right, so moving on to this one. This is a bear, all right? So we've got a lot of stuff going on up here. We've got a lot of negatives flying around. We are not just multiplying in one, we are dividing as well. So I've got 2 different operations in here. Oh dear, all right? So we're going to take it step by step, and I'm going to start the same way I have with every single problem. I'm going to start by factoring everything. All right. Okay. So starting in the first numerator. All right. I've got 3x squared minus 24x minus 27. All right. So I'm actually going to, because most of these factor twice, I'm going to factor the first time up here on the original problem. The second time will be down here as we get ready to simplify. All right. So here, got to check for a GCF, folks. Do not take this to your box or try your factoring method on this right away. Okay. You have to GCF this thing first. Check those numbers, 3, 24, 27. All 3 of those are divisible by 3. So I can take out a 3. What am I left with? X squared. Let's see, minus 24 divided by 3 is 8. 8x. And then minus 9. 27 divided by 3 is 9. That will factor twice. All right. So this will factor again. It's a trinomial. Okay. So I've got 3 times. All right. What are the factors of -9 that add back to -8? I should be looking for a -9 and a +1. So split my x's, -9, +1. Okay. The denominator on this first fraction, 81 minus x squared. We have seen this before. This still is difference of perfect squares. 81 is a perfect square. X squared is a perfect square. That is a difference. That is a check. We can factor that as difference of perfect squares. Now, normally we don't like things out of order like this. Technically, this is not in standard form. Okay. But with difference of perfect squares, we do not want to change it into standard form. Okay, because if you do, you get -x squared plus 81. That doesn't even look like difference of perfect squares anymore. And I have a negative to deal with out front. I just don't want to do that. Okay, I want to leave it alone. All right, so I'm going to factor it exactly the way it is. So two binomials, all right, square root of 81 is 9. Remember, you've got to keep difference of perfect squares in order, whether the number is up front or that constant's up front or it's in the back. Okay, so 9 up front, one gets a plus, one gets a minus. Square root of x squared is x. Okay, just giving you a moment to pause and look at everything that I've done. All right, so moving on. Next numerator. Woo, this one's gonna be good. Look at that bear right there. All right. Remember, always got to start with a GCF first. Can 2, 6, and 108 be divided by something? Hey, easy indicator. All three of those are even, so the answer to that is yes. Okay. All right. The next thing I don't like about this one, is I have a negative out front. I do not want a negative out front, guys. That means I have to factor out that negative. Okay, got to factor out that negative. I also have big exponents. All right, 5, 4, and 3. How many at most can I take from each one? Well, I can take 3 from each one of those. So my GCF here is not just going to be a sign. It's not just going to be a constant. It's going to be a full term with a coefficient and a variable and a negative sign. Okay, so I've got 3 different things to take here. So, all right, I'm going to take the negative out. All right, I'm going to take, let's see, the GCF between 2, 6, and 108 is 2. And then I can take at most 3 x's. So I've got a big GCF here. All right, so first things first, the negative is just going to flip the sign. All right, so now I have a positive term up front. Okay, so I've got, let's see, 2 divided by 2, it goes away. All right, that simplifies out. X to the 5th power divided by x cubed, that should just leave me with x squared. All right, flip my sign. Remember that when you factor that negative out, it doesn't just change the first sign, it changes every single one of them. All right, so plus, all right, dealt with the negative, 6 divided by 2 is 3. X to the 4th power divided by x cubed is x. All right, moving on to the third term. Flip the sign. I go to a negative. All right, notice each one of these are flipping upside down. All right, 108 divided by 2. Let's see, should be 54, I believe. Yes, 54. 54. Awesome. So the sign changed. I got the 54 from dividing by the 2. X cubed divided by x cubed. I don't need to add an x back here. Whew, that was a big GCF. Okay. But again, I've still got a trinomial to deal with. This will factor again. Okay. All right. So I got my GCF negative 2x cubed. And could I go, I wrote a squared cubed. Could I go ahead and split these x's right now into x times x times x? Yes, I absolutely could. Let's just go ahead and do that since we're talking about it. Okay, so I've got it, back to red, x times x times x. Okay, x times x times x. We'll just go ahead and spread everything out. All right. Okay, so let's factor this trinomial right here. So x squared plus 3x minus 54. What are the factors of negative 54 that add back to a positive 3? Let's see, 9 and 6, I believe. Yes, 9 and 6. So I should have a minus 6 and a plus 9 is what I'm looking for. All right, so I've still got these 2 binomials down here, x minus 6 and x plus 9. Woo, these are big ones. These factor a lot. All right, so moving on to the denominator, 6x cubed plus 18x squared plus 12x. All right, don't have a negative this time. Thank you, Lord. I don't have to deal with that. 6, 18, and 12, all 3 of those are absolutely divisible by 6, so I do have a GCF. I know I can pull a 6 out. But what else can I pull out? Take a second and look at all 3 of those terms. Can you see anything else that I can pull out? Absolutely. I can pull x, right? X, x, x. All three of them have an x, so I can take an x. At most, I can take 1 because my smallest exponent is a 1. Okay? All right. So what am I left with? All right. So 6 divided by 6 is 1. Don't have to write the 1. It's no longer needed. X cubed divided by x is x squared. All right. Plus 18 divided by 6 is 3. X squared divided by x is x. Plus 12 divided by 6 is 2. X divided by x, they're gone, right? They simplify out. Here's what I'm left with. And I have another trinomial to factor, right? Split my x's. Factors of 2 that add to 3 should be 2 and 1. Both positive this time. Okay, so I've got 6x. I've got x plus 1. And I've got x plus 2. Okay, but I'm still not done. I got this third fraction over here. Gosh, this one's taking forever. I know these suck, guys, but we got to get through them. Okay, all right, so moving on. This one, notice I do not have multiplication here. I have division. So what's going to happen to this fraction right here? It's going to flip, right? None of the other ones flip. They're multiplication, but this one specifically is division, so I got to flip it. All right, so I'm going to start by factoring everything, and I'm going to go the quick route this time. I'm actually going to go ahead and turn it into multiplication, and as I factor, I'll just flip the places of my factors. Okay, all right, so starting on the top, here's what I got. All right, so I know I have big exponents here, right? I have x's in each term. I can take a GCF. Let's start there. All right, so let's see. 4, 3, and 2, I can take at most 2 x's. All right, is there anything else I can take? The answer is no, absolutely. I don't have any signs to take and no numbers, no constants. All right, so what am I left with? I'm left with x squared minus 7x plus 6. Okay, so now I've got another trinomial to factor. And remember, these GCFs don't just go away. They are still, it's a greatest common factor. They are still a factor. We have to keep them. All right, so split my x's on this trinomial. All right, what are the factors of positive 6 that add back to a negative 7? Let's see, should be a negative 6 and a negative 1. Minus 6, minus 1. Remember, some of those can be negative on both ends depending on how your signs are arranged in the trinomial. Okay, so because this is division, remember, where's this one going to go? It was on the top. It's going to flip to the bottom. All right, so I've got x squared. Ooh, wrong color. X squared, x minus 6, x minus 1. Okay, go down to the bottom. He is very peculiar. He is very peculiar. He's not a trinomial. Okay, he is a binomial, but I still have a negative in the front. And do we like negatives in the front? No, we do not. A lot of GCFs involved in this problem. I have to divide out that negative 1. I have to GCF him out. Okay, so here's what I'm going to do. I'm going to divide by negative 1. Right? Divide by negative 1, divide by, take it out. And I'm going to be left with negative 1 times x plus 2. Okay, so I'm going to turn that. Now I have a factor that's a lot prettier and something I can probably cancel. All right, so this is going to turn into negative 1 and then x plus 2. Do not like negatives in the front at all. All right, so everything's set up for me to start simplifying. All right, so I'm going to go ahead and start simplifying what I can, and there's a lot here to look at, so just start finding matches and go to town. All right, the first match that I see is the plus 1, so plus 1, plus 1. Let's see, anything else? Plus 2, plus 2, minus 6, minus 6. And that is all I see for the time being. Those are the easy ones. Okay, those are the easy ones. I'm going to take what we have left, rewrite it, and we're going to talk about the hard ones. Okay, so down here, what am I left with? And I'm just going to write it all in one fraction, right? Because we extend that fraction line. I'm just going to write it all in one fraction. What am I left with up top? All right, I've got a 3. I've got an x minus 9. I've got a negative 2 and 3 x's. I've got an x plus 9. And I've still got this negative 1 over here, right? And I'm going to put everything in parentheses so we know they're multiplying. All right, that's still a lot left. All right, most of this is going to go away by the time we're done. All right, on the bottom, what do I have left? All right, I have 9 plus x, 9 minus x, a 6, and an x, and an x squared, which I forgot to break down. So let's go ahead and do that. X times x, right? That little sucker right there is x times x. Okay, so there's still a lot left. Well, okay, there's some simple things we can get rid of, right? We see pairs of x's. All right, so 1 pair, 2 pair. I can go ahead and get rid of those. Very awesome. All right, so don't look at the numbers for a second. I wanna not look at the numbers for a second. So I'm gonna cover him up, cover him up, cover him up. I don't want to look at the numbers anymore. Don't want to look at them. All right. Here's what I want to look at. I want to look at those binomials. Do you notice anything kind of funky about those binomials? They have the same numbers and same variables, but they're backwards, right? They are backwards. Well, I have an x plus 9 and a 9 plus x. Can I cancel those? Can I simplify those out? Yes, I absolutely can. Check this out. So what do we know about addition? Addition holds a certain property which allows us to switch stuff around. For example, listen to me for a second. What is 5 plus 3? 8. Okay. What is 3 plus 5? 8. All right. So it does not matter in which order I add them. So can I just say, oh, well, this is the same thing as x plus 9? Absolutely. Absolutely. All right. I can absolutely do that. So, sorry, got to get rid of this. I don't want to cover up my numbers forever. All right. I can absolutely go ahead and get rid of those. They are indeed the same thing. However, when I look at this pair, all right, x minus 9 and 9 minus x, are they the same thing? Are they the same thing? No, they are not. Subtraction is different. 5 minus 3. Well, 5 minus 3 is 2. Okay. 3 minus 5. Well, 3 minus 5 is negative 2. They are not the same. All right. So how do I make that x minus 9 instead of 9 minus x? Or do I just have to leave it? There is a way I can flip that factor around. All right, I can flip that factor around. Check this out. In this original binomial right here, notice I have a positive 9 and a negative x. Okay, notice up here I have a positive x and a negative 9. What do you notice about the signs on the 9s and the x's? They're just flipped. They're opposites. Right? In one, I have a positive, and one, I have a negative. So in reality, really, all I need to do is flip the signs, right? Really, all I need is a positive x and a negative 9. Well, wouldn't that just be negative 9 plus x? Well, yeah. But now I have addition in there. Can I flip those? Yes, I can. I can change that into x plus negative 9, or just x minus 9. That's all I need to do. I just need to flip it backwards. So what's that one thing I can factor out? What's that one number I can factor out to just flip signs? Absolutely, it is a negative 1. So if I pull a negative 1 out of this, it just flips it. X minus 9. Okay, does not, are you listening? Does not change the minus sign in the middle. All right. It flips the sign on each term. The 9 was positive. Now it's negative. The x was negative. Now it's positive. Okay. So I'm going to use this now, all right, instead of that. All right, so now check this out. Now I can get rid of those. They are now gone. Isn't that awesome? More stuff going away. Okay, what else can I also get rid of? Remember, I added a -1 down here, right? I factored out a -1 from that binomial. Well, check this out. Now I have a set of -1s that will also go away. All right, so what am I left with now? Now I am left with the 3, the -2, 1x up top, and that's it. Okay, on bottom, I'm left with the 6 and the x. Y'all still with me? Uh-oh, I have made a mistake somewhere. I'm forgetting something. Yes, I am, folks. Look, check it out. Woo, I forgot to bring down this x minus 1, x minus 1. That x minus 1 is still there. Okay, x minus 1 is still there. And I have another set of x's I can get rid of that we didn't see. Oh, third, bang, bang. There it is. Okay, so there's actually a little bit less. So really, sorry, I'll go write that. Don't mean to confuse you. I'll go rewrite that. All right, so I have the 3. I have the -2. And on bottom, I have the 6. And I have the x minus 1. This is where we're at. All right. So those numbers, that 3, that -2, I'm going to go ahead and multiply those, right? I'm going to multiply those together. Okay. So really, that is -6 up top and 6 times x minus 1 on the bottom. All right. Now, I also have another set that can go 6 and 6. Well, that number is gone up front. There's just a sign. Remember, everything's gone. What number do I replace it with? What's left? What did it simplify out to? It's a 1, right? So equals, I'm sorry, I'm running out of room here. Equals, right? Equals, I still have the negative up top. That didn't go away. There wasn't another match on the bottom to simplify him out, but I have the negative up top, 1, right? Because there's nothing left. And then just the x minus 1 on the bottom. And there's nothing else that can go away. So that is my final answer. That is a monster of a problem. And that one is actually harder than the ones that you're going to see. But I had to make sure, well, most of the ones that you're going to see, I had to make sure that I added in some specific cases in here dealing with all of the negatives. So don't freak out when you see this problem. They're not all going to be this bad. Some of them are going to be pretty good. Some of them are going to be a little bit easier. Okay. So if you have any questions, please feel free to email me or reach out to Mr. Twing. Let's get those answered as soon as possible. And that is multiplying and dividing rational functions, guys.